Hi guys, hopefully this is the last video. I missed that bit in question 9. I should have said that the second B1 mark was for the shape of the curve. So when you were doing the gradient function, you got 1 mark for intersections at 1, 2 and 3, 1 mark for the general shape. Okay, question 10. Trying to find the errors made by the student. Well, remembering our log laws, something isn't quite right here. The 2 seems to have jumped inside with the x. I'm not quite sure why. And there's definitely something going on around here because the base is 2 and yet the 2's become the power. So it's just trying to figure out how to write those and making it clear. So I think I might label them 1 and 2. So the first one, I'm going to say that 2 log to the base 2 of x should be log to the base 2 of x squared. And the second one, 3 squared, should be 2 cubed because 2 is the base. Right, now we need to solve it as well. It's only 2 marks, but we've already figured out most of where it's gone wrong, so I don't need to start from the beginning. I just need to start from that kind of 4th line down, because the x squared plus 1 is correct. I know that that should be x squared and not 2x, and I know that that should be 2 cubed. So all I need to do now, a bit of rearranging. X squared plus 1 equals 8x squared. 7x squared equals 1. So that means that x equals the square root of 1 over 7. Okay, let me tell you where the marks are, by the way, I forgot up here. B1 for each of those. Method 1 for that part. And accuracy 1. Let me undo that. And accuracy 1 for this. I'm only going for the positive, okay? If you put plus or minus here, you won't get that final mark. It can't be negative because you wouldn't be able to log it if it was negative, okay? You wouldn't be able to log it up here, so it can't be the negative one, only the positive one, okay? Okay, question 11. We've definitely looked at this one before. Part A. So using the factor theorem, show that x minus 1 is a factor. Okay, so if I plug 1 in, I should get 0 out. There's a lot of noise going on in the background of my kitchen, by the way. I think the heating's just come on. Because I've got 0 out, that means it's a factor, but I've got to do this step here, therefore x minus 1 is a factor. So there's my 2 marks here. You get 1 mark for the method, but you get 1 accuracy mark for this bit, which is actually using the factor theorem. Okay, part B, remember you've got a choice here. You can use algebraic division, you can also equate coefficients. I'm going to do algebraic division here just because I feel like I need a bit of a practice at it. So algebraic division means if I divide x minus 1 into my f of x, I should get 0 out because I know it's a factor. But then what I get over up here will tell me my other 2 factors. So x into x cubed goes x squared times by x squared, x cubed minus x squared. I'm going to take them away. I end up with 3x squared. Bring down the x. X into 3x squared goes plus 3x. I'm now going to times by it and I get 3x squared minus 3x. I'm going to take them away. I get 2x. I'm now going to bring down the 2 minus 2. X into 2x goes plus 2 plus 2. And I get 2x minus 2. When you take those away, you get 0. Okay, so now I need to figure out what x squared plus 3x plus 2 is as a quadratic, factorised into 2, x plus 1, x plus 2. Okay, now the question says express f of x as a product of 3 linear factors. I've not actually done that, so I am going to do that over here. So f of x equals the original factor, x plus 1 and x plus 2. So your marks, you get 1 mark for using algebraic division or equating coefficients. You get 1 mark for these 2 factors down here, and then 1 mark for putting them all together. Okay, now the final question, part C, I remember this being a little bit confusing, so I'm just going to get rid of all this. So I've got some space, and it says the point 0, 0 now lies on this curve. Okay, I remember a lot of you did algebra for this, and 2 marks not worth it. I'm going to sketch very badly. I don't know what happened there. I'm going to sketch what this curve looks like, okay, because I know it crosses at minus 2, minus 1 and 1, and this down here is minus 2. Now, this equation here, this has been transformed by this a. Okay, so all of the x's have been replaced with an a. And it's telling me that 0, 0 is one of the solutions. So 0, 0 is here, but what that actually means is that 0, 0, it could have been this point here, which has moved 2 to the right. It could have been that point there, which has moved 1 to the right. Or it might have been this point there, which has moved 1 to the left. So, there's 3 values. Sorry, I'll stick to red. There are 3 values of A. So, if A has moved 1 to the left, then that will be A being 1 in here, because if A was 1, a positive 1, that means 1 to the left. The other 2 are moving to the right, they would therefore be negative in there. So the other 2 are going to be minus 2 or minus 1. So it's a lot easier just to do by looking at a diagram and considering the transformation rather than algebraically. You get 1 mark if you've got one of the A values correct, 2 marks for all 3 A values correct. Okay, part 1 here, a couple of proof questions. Part 1. Sorry, wrong colour. Again, not great at this, am I? Thought I'd get better over time. Clearly not. Okay. We've got 2 cases here. So odd and even. Now with proof, if we're trying to prove something is always true for an even number, we're going to use 2n because it has to be even. And if 2n is even, 2n plus 1 is odd. I wouldn't use 2n minus 1 because if n is 0 here, then you get 1. If you used minus 1 instead of plus, then you could go into negative numbers. So just be a little bit careful with that. So I'm going to do case 1. So case 1 is n is even. And I'm going to let n equal 2k. And I'm just going to replace n in here with 2k and see what happens. Oops, that should be a minus 1, sorry. So, lovely bit of algebra here. Now, I have to admit, I haven't double checked this. If you find a mistake in here, please let me know. My only comfort was that it worked out, but it doesn't mean I've got it fully correct. So So I've expanded all this. I probably didn't have to. I think I've taken a harder route here. But at this point I've taken out 4. And what that then does, because I've removed a 4, because of that 4 there, this is divisible by 4. Therefore it's true for even n. Now I'm going to have to look at case 2. So that's case 1. I'm going to delete all this. And the second case is that n is odd. This was a lot harder algebra, I've got to say. And I don't think I've taken the easy approach. I've done it once and once only. Ideally, I would have double checked this. Okay, so I've plugged in 2k plus 1. And expanded all this out. Okay? I think what I'll do, I'm going to skip a couple of the lines of working that I've got. Actually, I won't. I'm just being lazy. So I've written it down already. Why be lazy now? So this is what I've got here. Then I've multiplied the first 2 brackets together. And then I've expanded both of these brackets. And this is where, if I've made a mistake, I've made it here. And I didn't even bother to collect like terms here because that's not what I'm trying to do. I'm trying to prove that it's a multiple of 4. So if I can do it without even simplifying stuff down, that's fine. So I've taken a 4 out here. And again, because I can take out 4, it must be a multiple of 4. So divisible by 4. Therefore true for odd n. Okay, so I'm just going to summarise this a little bit. So I'm going to say therefore n plus 2, n squared minus 1 is divisible by 4, and I'm going to use a fancy upside down a here for all integers. Because writing for all just takes too long, so why not use an upside down A? There we go. And unfortunately I deleted the first bit, so I can't tell you where the marks were, but you get a method mark for all of that beautiful work in there, and an accuracy mark for your kind of sum up of what it means. You get an accuracy mark for this final summary here as well. And you get the same marks for the even one. So you get the method mark and the accuracy one for the even ones there as well. Okay, so that's your 5 marks. Okay, second one, bit of a weird question, I've got to say. There we go, bye-bye. Okay, part 2. Without explicit calculation. Okay, so it just means don't actually multiply here. Try and do a little bit of manipulation, a bit of factorising, that kind of thing. So 40 squared plus 40 plus 41. Well, I'm going to take 40 out as a factor of the first 2 bits, okay? So out of here and here, 40 times 40 is 40 squared, 40 times 1 is 40, plus 41. Now I've got 41 here and 41 here, so I'm going to take 41 out as a factor. 41 times 40 plus 1, and I end up with 41 times 41 as required. Took me a few goes to get that one. It's a bit of a weird one. and it's only 1 mark, not the end of the world. But they've done it for a reason. You're going to need it down here. Okay? So, for part B, that should have been part A, sorry. So for part B, I don't know whether you noticed, but that looks very much like that. And she's saying this must be prime for each integer. Well, we've just plugged 40 in and proven that you get a square number. So she's not right. So using part A, let P equals 40, and what you get is that 40 squared plus 40 plus 41 is actually 41 times 41, which is clearly not prime. No square numbers are prime. So, sorry, Jyoti, you are wrong. There we go, she's wrong. Wrong. And you get 1 mark for finding the example. That doesn't work there. There might be others. It just makes sense to use the one that's in the question. Okay. Question here, we've got some coordinates, talking about lengths. Okay, so it's a very standard coordinate geometry question. So, again, look, wrong colour. What is wrong with me? Don't answer that question. Part A, find the value of P. Okay, well, we've been given 2 coordinates here, and they've also given us the distance. We know how to work out the distance. It's just Pythagoras. So we've got a coordinate here, A, which is 3, 6. B is minus 2P. So I'm going to start off by just using the formula for Pythagoras' theorem. And that should be equal to 5 root 5. I'm going to square both sides. 5 squared plus 6 minus p squared equals 125. So that's both sides squared. You can then expand all of that and we get a lovely quadratic in P. It simplifies down to p squared minus 12p minus 64 equals 0. Simplifies beautifully. And then we have 2 values of p, minus 4, 16. But actually it says up here p is less than 0. So because p is less than 0, we're going for that one there. Okay? Right, marks. So you get 1 method mark for attempting to use Pythagoras' theorem. You get 1 mark for getting down to a quadratic. And then you get your accuracy mark for finding the values of p and choosing the correct one. I've just realised my volume's been quite low, so I do hope it's not so low that you can't hear me. I'm just going to turn it up now, so I'm suddenly going to become a lot louder. Okay, lovely. So that's all part A done. Part B, perpendicular bisector. Okay, so perpendicular bisector means a line that is cut at right angles through the midpoint. So we're going to have to find the midpoint. So I'm just going to replace p there with minus 4. So for part B, before we work out the equation of the perpendicular bisector, a recap, we're going to need a gradient and a point. So our point is going to be the midpoint of AB. So the midpoint of AB, you add your 2 x's, add your 2 y's, halve them, and you get a half and 1. So that is your midpoint, and you get 1 just straightforward mark for working out the midpoint. Now we need the gradient. And we've already had a question where we've worked out the gradient using calculus, so differentiation. We haven't had to work out the gradient using change in y over change in x, so here it is. Once you've done enough papers, you begin to realise that there's certain questions they put on each paper. So that gives you 2, and there's a method mark there as well for working out the gradient. But I want the gradient of the perpendicular bisector. And please notice how I'm setting this out. It's very easy for the examiner to tell what I'm doing here. So the perpendicular bisector must be minus a half because the line perpendicular to it is 2. Okay, and I now want the equation of it. So I've got my point, I've got my gradient. I'm going to use this one, although when I got through it I kind of realised I hadn't, but I'm going to go with it. Y minus 1 equals minus a half, x minus a half, y minus 1 equals minus a half x plus a quarter, and then I just added 1 onto the other side. And this is perfectly fine because it doesn't actually say in the question what form to have it in. Okay, it doesn't say at all, so this is absolutely fine. So I've got a method 1 mark for this and an accuracy mark. I've done it again. I've actually got a point on my pen that if I press it, it suddenly becomes an eraser, and I've not yet been able to figure out where it is. So there's my 5 marks, 1, 2, 3, 4, 5, yeah, I'm just checking. And now it says a perpendicular bisector intersects the coordinate axes at points C and D. Finally, I have the triangle. Okay, lovely. Well, let me get rid of this so I've got space. That sounds quite tricky, but it's only 2 marks, so it can't be that challenging. I'm going to start off with a little sketch. So, I've got my points A and B. There's A, there's B. And I'm going to roughly draw a perpendicular bisector through the midpoints. And I'm going to put C up here and D down here. And this has got equation minus a half x plus 5 over 4. And I basically want the coordinates where this crosses the axis and that crosses the axis. So down here, what happens when y equals 0? And here, what happens when x equals 0? Okay, so into my equation, I'm going to look at if x equals 0. Well, if x equals 0, I can just cover this bit up and I get 5 over 4. And if I let y equal 0, then I'm going to bring the negative 5 over 4 here, divide by negative a half. So if y equals 0, I end up with x equals 5 over 2. So I get a method mark for